Okay, so here we're gonna compute some derivatives of these functions, but what we have to keep in mind is that we do not yet have the chain rule, and I kind of like this little game that they make us do now, where we have to find the derivative of some of these functions without the chain rule. So let's take this first one, and the chain rule wouldn't help us in this one anyway, so it's a good one to start with. So what we do is we need to know that the derivative of a sum is the sum of derivatives. So that means that I can find the derivative of this one, plus the derivative of this one, plus the derivative of this, plus the derivative of this, or minus the derivative of that, but whatever. Okay, so the derivative of this first one, right? You pull out the constant, 4 times the derivative of x to the fourth. In the derivative of x to the fourth, we use the rule that the derivative of x to the n is n times x to the n minus 1. So that means that the 4 comes down, x, and then the exponent goes down by 1, x to the third. Plus, the derivative of this one, the 2 comes out, and then you got to find the derivative of x squared. The 2 comes down, so the 2 came out, the original 2. The 2 comes down, and then the exponent is diminished by 1. The derivative of a constant is 0. Derivative of -5 or 5 is 0. That's right here now. And then plus, again, same thing, I pull out the 3, times the -5 comes down, times -5. And then the exponent is diminished by 1, that makes it -6. And then now I just simplify a little bit. 4 times 4 is 16, x to the third, plus 2 times 2 is 4, times x, the 0 I don't care about, minus 15, because 3 times -5 is -15, x to the -6. If we want our exponents to be positive, then we would move the x to the -6 down. This would be, if I called this f of x, then this is f prime of x. This here would be f prime of x. Okay, now that's fairly, straightforward. Not too difficult. Here it involves a creative step, okay, for this sine 2x. Without the chain rule, right? So once we learn the chain rule, finding the derivative for this will be a little bit easier, but without the chain rule, the only way I see doing this is to use the double angle formula for sine. So the double angle formula for sine is, so I know this sum formula, it's 2 sine x cosine x, I believe. And now finding, so this is directly equal. I shouldn't have put, this is, if this is f of x, then this is the same thing. This is f of x. And my task is to find f prime of x. And in this case, what you could do is you could forget about the 2, and you could differentiate sine x times cosine x. Okay, so that would be the derivative, right? I purposely put the derivative symbol so that way this actually is f prime of x, and the way you find sine x times cosine x is using the product rule. We have to remember what the product rule is, and we have to know how to use it. So the derivative of f times g, f and g are two functions, is f prime, the derivative of f times the function g, plus the derivative of g times the function f. Now in this case, right, I guess I shouldn't have used f here, but whatever. This takes the role of f, this takes the role of g. We should use a different name for this, whatever, we'll call it h of x. Okay, let's say this is h of x, just not to get confused with this f that I'm having here. And then now I just apply it here, right? So now I can see that this is a product, right? I'm looking for the derivative of f times g. So what does this mean? It means that it's going to be the derivative of sine times g, the role of g is cosine x, plus the derivative of cosine x times sine. And then now I just need to know that the derivative of sine x is cosine x. Okay, so this becomes cosine times cosine, cosine squared x, plus the derivative of cosine we need to know is negative sine x. So it becomes negative sine x, sine squared x, because this becomes negative sine. So it's just minus, and then the whole thing becomes cosine squared x minus sine squared x. And then this here is f prime of g, which I actually think, then, oh, sorry, and then we plug back in, and this is an interesting fact. This is good because now I can see how it all relates back and that we did this correct if we did it the other way, because I can use the chain rule to check my work. And I just did that, and let's see what I got. So basically I'm saying h prime of x is equal to 2 times the derivative of this, right? Sine x times cosine x. I just found that derivative. That's cosine x times sine. That's, yeah, cosine squared x minus sine squared x. But now I actually know that this here is, if I go back and if I'm really good at knowing my cosine double angle formulas or my sine double angle formula, that this is actually cosine of 2x. And that's good, because if you use chain rule on this to find the derivative, you do get this right away. So I just did it this long way about because I cannot, because I don't yet know chain rule. Okay, and this next one, what we have here is that we just use rules of log and then know that the derivative of log x is 1 over x. So what's the rule of log? The 4 can come down, 4, so this is equal, right? These two are equal, and then I want to find the derivative of this. So the 4 can come out, and then it's just the derivative of log x, and then this is 4 times 1 over x, and then the derivative is well, it's no longer equal, but yeah, then it's gonna be 4 over x is the derivative of this whole thing. So if I wrote it correctly, prime, I'm looking for the derivative. Now there's equality among everything here. You could say everything is equal. And the derivative of log x to the 4th is just 4 over x. And again, you would get the same thing if you use chain rule on this one here. So we can see that chain rule is going to help us out with finding derivatives. We won't need to know the double angle formula for sine or to know that this here is actually cosine 2x. Okay, the double angle for cosine. We wouldn't need to know that. We would just be able to take the derivative and go right to here. But it's fun to sit here and try and figure out how we could actually get the derivative without knowing chain rule.